All right, let's get into it. For the longest time, the world's data lived in this really neat, super orderly neighborhood. All tables, rows, and columns. But then the internet just exploded, and with it came this flood of data. So massive, so complex, and so interconnected that it shattered all the old rules. This is the story of how our data basically outgrew its home, and how a new generation of builders had to create a whole new toolbox to handle it. And that really brings us to the central question, doesn't it? When giants like Google were laying the groundwork for the web as we know it, why couldn't they just use the same databases that had been reliably running businesses for decades? I mean, what was so different about their problem that they had to go and invent their own? The answer to that question completely changed how we all think about storing information. So, to really get the revolution, we've got to understand the old king. For decades, one model absolutely reigned supreme: the relational database. It was the bedrock of computing, organizing everything with this powerful, elegant logic that honestly seemed like it would last forever. And the power of this model was its beautiful simplicity. Everything had a specific place. You'd have a table for your customers and another table for their orders. Each customer gets a unique ID, that's your primary key. Then, to link an order to that customer, you just pop that ID into the orders table, that's the foreign key. It's a brilliant system for making sure you don't repeat yourself and that all your data stays consistent and accurate. And because it was just so darn reliable, it became the default choice. If you were building an application, you were using a relational database, period. Didn't matter if it was a banking system or inventory management, this structured, table-first approach was the foundation for everything. It was battle-tested, it was trusted, and you know what? It just worked. But the web brought challenges on a scale that nobody had ever imagined. We're talking about a fire hose of user data, interconnected content, and data types that were changing all the time. And that solid, reliable foundation of the relational model, well, it started to show some serious cracks under all that pressure. And this quote from Google Research just nails the new reality. They weren't dealing with gigabytes anymore. They were staring down petabytes of data. That's millions of gigabytes. They needed something that could handle the entire web index, or all of Google Earth's satellite images, spread out over thousands of regular computers. This wasn't just a bigger problem. It was a whole new species of problem. So what was the actual breaking point? Where did it all fall down? Well, it really came down to one single fundamental operation: the join. The join is how relational databases connect the dots between tables, matching that foreign key in one table to the primary key in another. And it's great for simple lookups, but it becomes incredibly, painfully slow when your data has tons and tons of connections. This graph right here tells the whole story. Just look at that orange line. That's the performance of a relational database as you keep adding more connections, more joins. It doesn't just get slower, it falls off a cliff. Asking a question like, show me the friends of my friend's friends, becomes a computational nightmare. Now that blue line, that's a different way of doing things, a graph traversal. Notice how it stays flat and fast no matter how deep you go. And this wasn't just a problem for social media. Think about e-commerce. As you can see in this table, trying to model a complex product catalog in a relational database is, well, it's a mess. A book has an author. A movie has a director. Trying to cram all these different shapes of data into rigid tables means you're doing joins all over the place. And if you want to add a new type of product, you have to change the entire database blueprint, the schema, which is a massive headache for developers. And this is the crucial turning point. The industry realized that the one-size-fits-all era was over. The solution wasn't about finding one new database to replace the old one. It was about building a whole toolbox of specialized tools. This movement got the name NoSQL, which is a bit confusing. It doesn't mean no to SQL. It really means not only SQL. And inside this new toolbox, a few key players started to emerge. For our story, there are a couple of really important ones. You've got document databases, which were built to solve that problem of complex, evolving data, like those messy product catalogs. And then you have graph databases, which were designed from the ground up for highly connected data where the relationships themselves are the most important thing. Okay, so let's grab that first tool from our toolbox and see how it fixes that messy product catalog problem. How do you handle data that just refuses to fit neatly into rows and columns? Well, the answer is kind of beautiful in its simplicity. You just stop trying to force it. With a document database, each product is its own self-contained package of information. The book on the left has all of its unique details, like the author and number of pages. The movie on the right has its own stuff, like the director and runtime. They have completely different structures, but they can live happily side by side in the same database. No problem. And the benefit is immediate and huge. Because all the info for one product is in one place, you don't need any of those slow, complicated joins to piece it all together. A developer can add a brand new product type tomorrow with a totally new set of features without having to redesign the entire database. It's just so much more agile, simple, and fast. And listen, this isn't just some abstract idea. This is the engine that powers modern e-commerce. You can see how a flexible database like this sits right at the heart of the whole system. It's pulling in data from all kinds of places on the left, social media, CRM systems, and then it's powering everything you see on the right, from the website and mobile apps to all the internal tools. This is how the big players do. Okay, but what about that performance graph we saw? What happens when the connections between your data are actually more important than the data points themselves? For that kind of problem, we need to pull a different tool from our toolbox, the graph database. So instead of thinking in tables, a graph database thinks in terms of nodes and relationships. A node is a thing, a person, a product, a bank account. And a relationship is the direct explicit connection between them, like friend of, purchased, or works for. It's not just a reference like a foreign key. That connection is a real, tangible part of the data. And the way you ask questions of this data is just cool. Using a query language like Cypher, you basically draw the pattern you're looking for with text. A query might look like this: user-friend of-friend. That literally means find me a node I've called user that has a friend of relationship pointing to another node. It's an incredibly intuitive way to go exploring through all those connections. And this brings us right back to that core performance difference. A relational database has to figure out the relationships every single time you ask by scanning tables and matching keys. That's the slow join operation. A graph database, on the other hand, just follows the connections that are already stored, like following a series of pre-built pathways. That's why its performance stays consistent, while the join just gets slower and slower and slower. So here's the ultimate takeaway. The evolution of databases wasn't about finding one winner to rule them all. It was about finally acknowledging that data has a shape. Sometimes it looks like a neat table, and sometimes it looks like a big interconnected network. The real key is choosing the right tool for the job. This table pretty much sums it all up. Think of it as your cheat sheet. If your data is highly structured, fits nicely into tables, and your relationships are pretty straightforward, a relational database is still a fantastic, super powerful choice. But if your whole world revolves around complex relationships, finding patterns, and tracing paths, then a graph database is literally built from the ground up to crush it at exactly that. So we'll leave you with this final thought. Every single application, every project, every business, it all has data with its own unique shape. The most important question a developer or an architect can ask today isn't which database is the best anymore. It's, are we using the right tools for the unique shape of our data?